At this time, I'd like to introduce our first presenter. Krista Poss is Marketing Manager for System Sensor. Krista, take it away.
Hi, everyone. Thank you, David. Thank you to all of you, first of all, for taking the time out of your busy day to join our webinar. We do appreciate it. As an agenda for today, I wanted to provide some examples of unconventional applications for aspirating smoke detectors that you may or may not be familiar with, as well as review some real FAAST installations that have actually employed aspirating detection technology in these very environments that we talk about. I'm also joined today by Luis Barros. Luis is the FAAST sales engineer. He's going to go through some common questions that we have been asked in terms of challenging applications for aspirating detection. So he'll go through some common questions and answers that we get. And he'll also provide a brief overview of the FAAST technology. So like David said, we will open it up for any questions that you may have about specific applications. Many of the applications and case studies that I reference can be found on the FAAST website with more detail provided. So if you're interested, you can find it there. Okay, so let's get started with that. This slide is probably most likely a review for most of you, but we wanted to provide a general overview for anyone who might be new to the technology. So at its most basic level, an aspirating smoke detector is a detector that actively draws air samples into its sensor for the purpose of detecting smoke. So typically, an aspirating detector uses an aspirator, which is also known as a fan, to draw air samples through a network of piping that ends in a sampling point that extends into the protected space. Once the air sample is drawn into the device, it passes through a filtering element and then into the sensing chamber for the purpose of detecting any smoke. Historically, in order to provide early warning or very early warning fire detection, aspirating smoke detectors have used a highly sensitive infrared laser-based detection source. Recently, though, newer modes of detection have been introduced that provide higher level of nuisance immunity while still providing the high sensitivity to smoke necessary to provide that very early warning fire detection. So we'll talk a little bit more about that later in the presentation. So let's get into some common applications. Many applications for aspirating smoke detection require the detector to provide early or very early warning fire detection per NFPA 76, which this is the standard for protection of telecommunications facilities. So the goal here of this approach is to detect incipient fire conditions early enough so that facility managers can take proactive measures to reduce the risk of fire and smoke damage in these applications. So multiple levels of alert can also enable responses customized to the incident severity so that, we're not responding to things that, are very small. But it's not surprising that buildings that have to operate 24/7 or have highly sensitive or high-value property will often use aspirating smoke detectors to protect those environments. Aspirating smoke detectors also offer flexibility in their placements. So because these detectors can cover a large area through the piping network, the detector itself can be mounted outside the protected space. So this allows end users or technicians to easily access the detector without actually having to enter that protected space. So that lends itself to some more of these challenging applications for standard smoke detectors. In addition, the ability to cover large areas while being mounted outside the protected space also enables aspirating detectors to be used in areas where ambient conditions can hinder the performance of a standard spot detector. So these might be areas with extreme environmental conditions, high rates of air change, or very large open spaces. So now we'll talk through some specific examples and case studies of these very applications. So the first one is, I think, where most of us go when we think of ASDs is this mission-critical market. So smoke detection here is difficult because of high airflow created by the CRAC units, which stands for computer room air conditioning, and unique airflows created by some newer data center configuration methods, such as hot aisle and cold aisles. So not only can a fire damage a data center, but smoke can corrode the components and then increase the risk of equipment failure in the future. So due to the concentration of cabling, cabinets, high heat equipment, the possibility of smoke and fire can certainly be heightened in these environments. Because of this environment, it's necessary to put smoke detection in several places throughout a server room, depending on its layout. So this could include under the floor in the case of a subplenum, in the ceiling plenum in the airflow path to the return air unit, for hot aisles where the air is exiting the row into the ceiling, and the return air grill up the CRAC unit. So aspiration works in these environments because the pipe network can be run throughout the plenum spaces and along the path, which air will travel, providing a wide area of detection with the flexible pipe network. The high sensitivity of an aspirating detector allows for that very early warning of smoke, so there is time for proactive responses before an actual fire event could ever occur. And again, because ASDs are actively drawing in the air, they can overcome the effects of the high airflow in these environments. So now we'll look at a case study. This is the Cyber Innovation Center in Louisiana. It's a state-of-the-art facility that also incorporates a data center. And in this specific application, they employed a hot aisle cooling technique where chilled air is forced into the room and subsequently pulled through the rack into a hot aisle. The hot air then rises to the ceiling plenum where it's returned to the CRAC and then recirculated. So this created a high air velocity environment, which is challenging for standard smoke detectors. So FAAST was used to adjust to this high airflow and as the first trip on a two-stage pre-action system. And this is one of the case studies that I mentioned. If you're interested in learning more about it, we do have a published article on our website. So next, let's move to an application that you might not always think of when we're talking about ASDs, and that's harsh environments. So the opposite end of this spectrum. But harsh environments cover a wide variety of applications. So this could be dirty, dusty manufacturing and food processing facilities, to facilities with corrosive chemical vapors in the air. Any space where traditional detection could not survive, ASDs may provide a solution here. These areas may have high or low temperature extremes, which preclude the use of spot detection. They also may have a high risk of quickly escalating fires due to chemicals present that require high sensitivity. They may be very dirty, and traditional detection is prone to false alarms or very frequent maintenance. So ASDs can also be a great solution for harsh environments in the case of the temperature extremes. This is because the detector can be mounted remotely, and then the air can either be heated or cooled to the appropriate temperature before it's sampled by the device. This thinking works similarly for corrosive applications. So again, the detector can be mounted remotely from the space, prolonging the device's lifespan versus alternative types of detection, which would probably require to be mounted in contact with the harsh chemicals, and which would definitely shorten their lifespan. So thinking of these dirty and dusty environments such as grain silos, cocoa processing plants, or even animal barns, many aspirating smoke detectors utilize various stages of filtration to eliminate nuisance particulate from the sample, which then maintains the device's sensitivity while reducing the occurrence of nuisance alarms. And Luis will talk more about how FAAST does filtration in a few more slides to give you some more examples there. Now let's look at a case study. This is a tool manufacturing plant. The Apex Tool Company is a billion-dollar tool manufacturing plant. They have a hand tool plant in North Carolina and they needed to put smoke detection into their switchgear rooms, which is a very caustic environment. So the production process led to a high concentration of dirty airborne particulate, and this was causing constant maintenance conditions to the spot detectors that they had employed, which were causing false alarms. So they decided to use FAAST for the switchgear room because of its nuisance immunity, and it was set up as an early warning system tied to a strategic response plan. An interesting note on this one is that at one point there was a smoke event that occurred on the floor, which leaked into the switchgear room. FAAST detected the smoke, which was reported back to the guard station as dictated by the procedure they had in place. The guard went to do a visual inspection. He determined that the switch room was not at risk, and the smoke had come from an area of the production floor. But this proved that the FAAST device did exactly what they had set it up to do. Okay, another harsh case study that we want to look at is a chemical plant. The chemical plant needed smoke detection in its motor control center. Shutting down this room to install smoke detection would have been extremely costly to the plant, and it was not an option. So they had to look for other options for smoke detection in this application. Further complicating detection, there was high air velocity. Air handlers were kept in place to keep the room at a cool temperature, which made airflow very challenging for standard spot detectors. So again, because of its flexible network of pipes that could be run through existing cable trays that were already in place, the capillary points could be dropped from the main pipe to sampling areas. The technicians in this plant were able to install FAAST without interrupting the plant's production processes at all. The last study we want to look at for harsh is a pharmaceutical manufacturer which produced coal tablet pills. As a result of the production, the space had a lot of fine airborne coal particulate, and smoke detection had been installed in the return air duct, but it was constantly false alarming due to this, this airborne particulate that was always there. FAAST replaced the existing smoke detection methodology because of the filtration process that it used and the dual light source technology. They were able to alleviate the false alarm problems that they had experienced when they were using just standard spot detection in this plant. David, we're going to stop here for our first poll question.
All right, thank you. So this is a time, if you would, visit your screens and then click on the response that is most applicable to you or your business. And you'll notice here an other category. So other would be everything else. And if you could, spend a moment and send us via chat what other might be. So here's the question. What is the most challenging issue to overcome while providing smoke detection? We've listed a couple more obvious ones, perhaps: large open spaces, extreme temperatures, tamper resistance, harsh environments, as Krista was just talking about, or other. So perhaps you have one that isn't on that list that you would click. So if you do click other, if you take a moment and just send us via chat what that is, and we'll post these results. And also just a reminder, we do encourage you to ask questions. Krista and Luis, we do have a couple of questions posted here that I'd love to take at this time. The first question that's posted is, what's the difference between early warning and very early warning in terms of smoke detectors?
Okay, would you like me to? I can answer that.
Sure.
The difference between the early warning and very early warning is the coverage on which a sample port or a spot type detector, if you're designing for that category, is going to cover. So for early warning, it's a 400 square foot spacing for a sample hole, and for very early warning, it's a 200 square foot spacing. So as far as the space goes, it's just a matter of you're going to have more sample holes or less sample holes depending on the category. So you will have more sample holes for very early warning, and you have less for early warning. And then, of course, standard detection traditionally or typically is 900 square feet.
Okay. Okay, all right. And just so everyone knows, that's Louis Sparrows, the sales engineer for the Aspiration product category. Next question that came in harsh environments, are there specific maintenance or cleaning requirements?
Yeah, sure. Again, as Krista mentioned, as far as filtration, which I'll talk about later on, there are no need for additional filters. But as far as cleaning and maintenance, we do monitor the airflow. So if the sample ports, let's say in this environment, are starting to clog, we will let you know, or the product, I should say, will let you know of that. And then the simple cleaning, which is called out in our installation manual, is disconnecting of the tube and the network up to the detector, and then blowing, compressed air back through the pipe network to clean out all the ports. So it's air, compressed air, or vacuuming of the ports.
Okay, very good. I just posted the poll results. We had 75% of our attendees vote, so thank you for that. And it looks like the big winner by a small margin actually is harsh environments, followed by open spaces. So, and some of the chat that came in here, hot and cold aisles came in. Let's see. That was, I guess, the only challenging issue, retrofit applications in a congested or confined non-plenum space.
Okay.
Or other ones that people submitted. So thank you for that. I'll take the poll results down, and I think, Krista, it's back with you.
Okay. Thanks, David, and thanks, everyone, for voting. Next, we'll talk about large open spaces. So these can be problematic for traditional detection for several reasons, the most basic being the area itself. So large open spaces, those with high ceilings, can really be very problematic to service. In some cases, most of you probably know, a scissor lift might be needed to reach ceiling-mounted detectors, which can be costly and disruptive if it's a public space where people are working or commuting through. So aspiration detection can be mounted at the floor level, and then the pipe run to the ceiling and throughout the area, providing full coverage at an easy-to-access point for servicing. So ASD's high level of sensitivity can also overcome the effects that dilution can have in these large areas. Another issue in these large open spaces is stratification, which is simply temperature differentials which may stop smoke from reaching high levels in these large spaces, especially if it's a low energy fire. So due to stratification, a spot detector may never see smoke if it's mounted to the ceiling. Pipes from an aspirated unit can be run up and drop down support columns or any other type of infrastructure that may be there. Or capillary points could be suspended from ceiling-mounted pipe to, again, overcome the stratification barrier, which could be caused by these temperature differentials. So a real application that employed this practice is a new airport in India selected FAAST to protect its large open terminal building. So many of you can, imagine an airport, and many of them have large open spaces that's very challenging to use standard detection. This terminal also has large sloped glass ceilings in which the height grows from 30 to 65 feet. So aspiration detection was selected as part of a systematic approach to the fire protection throughout this building. Air sampling pipe was installed along the slope of the ceiling to detect smoke at the higher levels, while high sensitivity duct detectors monitor air circulating in the HVAC system to protect the building at the lower levels. We're going to move on to what we call access restricted. Typically when we talk about these areas where access is restricted, a lot of times we're referring to detention centers, juvenile centers, and jails in which there is a major concern, first for tampering with or destroying spot-type detectors. This could create a security concern, as well as frequent service or maintenance within that restricted area. It's difficult. It's also difficult to access the detectors for annual maintenance and testing inspections. So a lot of prisons are looking at aspiration detection to be utilized in these areas to provide detection within each cell while keeping the detector in an area that is accessible only to the staff or the technicians. So we're certainly seeing a trend here. It seems to be a problem solver for issues with standard spot detectors. An installation in Canada, the Manitoba Detention Center, employed this type of application. So the aspiration detector is used to take samples from each cell. A single channel device was chosen because they wanted to provide exact addressability. They also chose aspiration because of its ease of maintenance and service. So there's no need to go into each individual cell to test or maintain devices, which is obviously disruptive for everyone involved. It also, again, removes the issue of tamper concerns that can be an issue with standard detectors. So sample points are much less prone to being destroyed or tampered. They also replaced detectors in the air supply vents that were prone to trouble conditions due to dust buildup in this environment. So that's another issue that FAAST addressed in this typical, or in this application in the detention center. Switching gears again, let's talk a little bit about aesthetics. I think we all understand the issue of aesthetics when it comes to providing protection in certain applications such as museums, art galleries, historical properties, even high-end residences. Architects and engineers want to provide protection, but there's certainly a concern for preserving the integrity of the building. There could also be a concern of providing detection in unreachable and limited ceiling cavities in some of these buildings as well. So it's sometimes a combination of the structure of the building, aesthetics, and that's where aspiration detection allows the best protection with minimal impact to aesthetics. So with the discrete sampling points, and again, the ability to mount the detector anywhere, it's really a solid solution for a lot of these types of applications. The last case study I'll talk about is the Minnesota History Museum. This employs a couple of the things we talked about so far. So they are concerned about safeguarding precious objects and artifacts while protecting the patrons from a fire event. So they employed a comprehensive fire and life safety system. The museum thought it was prepared until an electrical wire issue caused a small fire within one of the exhibits. It wasn't detected by the standard smoke detectors because the ceilings in this building are very high. So the museum staff was introduced to FAAST as a technology that could provide very early warning as well as address aesthetic concerns that they had for the historical building. So again, in this application, FAAST was able to address a few different needs that the building had where standard detection was a challenge. And with that, David, let's move to our second poll question.
All right, very good. So the second poll question is a yes-no. And if you do answer yes, we would encourage you to send a chat with what other applications are involved. So have you used ASD in the past for applications other than mission critical? So we've identified a few here that we know are pretty commonly in use in some areas. And we're just wondering from our audience on today's webinar if in fact you have experienced those similar types, or are you mainly focused on that data center, financial center, you know, really where the technology is designed to be protected. So go ahead and vote. Guys, we do have another couple other poll questions, or a couple other questions that have been posted. The first one I can answer. They're wondering if there's going to be an archive of this webinar. Yes, there will be. Should be posted in a couple days at systemsensor.com under training. Luis, this one might be a good one for you. Are we going to cover designing for hot or cold aisles, or where could they figure out how to do that, to the application of hot and cold aisles?
Absolutely. As far as on this webinar, due to the nature of the time constraints we're on, we're not going to cover that in detail, but we definitely do encourage, which we'll talk about at the end of the seminar. We do have an online form in which, if you're looking for us to assist on a design of a hot or cold aisle, fill out the form. It will get sent to our dedicated design team, and then we will look at that and design that accordingly, and and assist as well if we need to. Maybe they're looking to just some guidance. We can provide that as well. They can just reach out to us.
So an in-house design resource within System Sensor. Okay.
It's just that we can't do it on this due to the time.
Sure, you bet. The next question deals with high. They're saying about flow with high rate of change, and I'm guessing it's airflow. How does the FAAST unit, or how does aspiration work in an environment where you have a high rate of change?
Well, as far as high rate of change, when that's something to look at when you're designing the system. Mainly when you're high rate of change, the primary area to focus on detection is going to be the return air grills. So if it, as Krista mentioned, if it's going to be a cracked standalone unit, or if it's maybe the building system, you do want to protect that primarily, and then it's space protection, and then depending on if it's cabinet protection and so forth. It all depends on the change. Now, as far as standard detection, as far as standard detection goes, per NFPA, you do have to reduce the coverage per sample hole. That's why I mentioned earlier. Traditionally, it's 900 square feet, but based on number of changes per hour, you do have to reduce that, and that's all again has to be taken based on measurements done at that location.
Okay, very good. Let me go ahead and post the poll results. They're pretty interesting. It looks like very high percentage have used ASD in past applications other than mission critical. No is 3 out of 4 responses. And then what's interesting here, guys, is the type of the chats that are coming in are they've used it in a telephone central switch operation. They've used it in a duct detector in a shielded room. They've used ASD in high-end homes to protect paintings and other valuable items. Let's see. Correctional facilities, cultural heritage museums, protecting switchgear. So lots of really good applications outside of mission critical that our attendees are involved with here.
Good.
So I took that down, and I believe, Luis, you're going to take it from here.
Okay. Let's see. Great. Thank you. Thank you, Krista. Well, good afternoon. First of all, good afternoon, everybody, and good morning to those of you attending on the West Coast. The next set of slides, I just basically want to cover some of the frequently asked questions that we get. Do I have? Yeah, here we go. That we get when dealing with those type of applications that Krista had mentioned. Again, basic. We do take each one. You have to look at each one individually. But these are some of the questions that we get from these applications. In the first scenario, as Krista mentioned, if it's a historic site, or even a couple of customers mentioned on the poll question, high-end residential applications, we have been working with some architect and engineering firms where spot-type detectors are just too obtrusive to have in that environment. And so they were looking to see if they can use air sampling to provide that protection. And the answer is yes. While the main trunk and the main tubing can be hidden outside of view, you would then use flex tubing and capillary points in that space. So as far as the obtrusiveness, you're not going to have that. If you want to look at the most common, they come in, capillary points come in a number of sizes and shapes. And the most common is it's a flush plate, similar to, here's a side view. It's very, it almost looks like the sprinkler plate with a pinhole on it, and that's your sampling point. And that can be your standard detection coverage, 900 square feet typically, or it can be your early warning or your very early warning coverage. So that's one scenario that we get questions on. The second scenario we get is the area they're looking to protect is high humidity or prone to condensation. Is this a problem? Well, with traditional spot-type detectors, especially photoelectric type principles, definitely a problem because of the nature of the technology. If any moisture gets into that chamber, it could act and respond as unwanted nuisance alarms. So, with air sampling detection, what you would have is you have as far as a sampling network, you have the detector located outside of that environment. It may be even a duct detector outside of that environment, and then having the pipe network in that high humidity condensation environment. As the sampled air is coming through, if there's still condensation or moisture present, then we do have recommendations on drip loops or moisture traps or water traps that you can put in line to prevent that and to catch that. So it is ideal for these type of applications. Another application is areas I need to protect, as Krista mentioned. There's the application is it's a harsh environment. You still need to provide smoke detection there, but it's challenging because of the airborne particulates. What do I need? What kind of extra filtration, if I do choose to use air sampling, do I need? With FAAST, it's none. Basically, there is no additional filters needed built into the unit itself. There's 3 stages of filtration. The first stage is the particle separator. Is this item here that you see on the left. Basically, that's embedded, or that's built into the unit. As the sampled air comes through and into the detector, the first stage it hits is the particle separator. Any large particulates, dust, or debris basically gets filtered from the particle separator, and it's get exhausted right back into the space via the exhaust tube. Anything smaller will then travel up the center, that center channel there, out of that particle separator to our next stage of filtration, which is our 30-micron filter, which is the one on the right. Now, we monitor the airflow. I did see a question. The gentleman asked me if I indicate if it's a single hole detection. No, it's a percentage of change. So if there was a 20% change to the airflow, that's when we will indicate trouble on the piping network, also on the filter. So it is measured across the filter. It isn't a time. Like historically. It's when the detector will tell you when it needs to be replaced. So it's the first level of you get an alert. The first level, you have 72 hours to correct that. If it's not, then it turns into an urgent trouble, letting you know that the filter definitely needs to be replaced. And it's just a simple, it's just simply removing 2 screws on that filter cartridge, and then inserting the new filter cartridge and tightening down the screws. There is no certification needed by by whomever doing the filter replacement. It's just a matter of replacing that filter and inserting the new filter in place. But the product will tell you when the filter needs to be replaced. So and then the third stage of filtration is the chamber, which with the use of the infrared and the blue LED, infrared and blue LED inside the chamber, if any particulate were to pass through the particle separator, then the filter, and then enter the chamber, it's being sampled by both sources. If it's a dust particulate, non-particle combustion, we reject it, and if it's a particle combustion, we confirm it with the blue LED very accurately. So no additional filters needed. The next scenario, I need to monitor, we get this a lot, we're monitoring the return air grill or supply air grill to an environment. FAAST is listed for duct detector use. So as Krista mentioned, the detector could be situated in one area while the sampling tubes goes up and into the ductwork, sampling the air into the ductwork. And we do have online, we do have a white paper or application guide that will step you through certain things to look for when employing for a duct detector. And it may be, the number of sample holes based on the size of the duct detector or height of the duct detector if you're going to need a couple of sample pipes. Another scenario we get is if it's low or high temperature environments that you need to protect, which are outside of the listed range of the detector. The FAAST unit itself, the electronics, it's rated from 32 to 100 degrees Fahrenheit. However, the sampling air temperature is -4 to 140. So if you're looking at protecting possibly a refrigeration area or a freezer area, we also have a white paper that will assist you on the guidelines around that, but it's just a matter of bringing that sample air within that temperature range, so that -4 to 140. So if it's a freezer, for example, and it's colder than -4, the white paper we show you how to, approaches on how to heat that air, prior to coming into the detector, so you're within that range. And also cooling it if you're in a high temperature, if it's higher than 140, how to cool that air down prior to entering the detector. So yes, you can detect in those spaces, and the temperature is not going to affect the detection. Next scenario, which is also a common scenario, is smoke detector per code is going to require in beam pockets. Traditional detectors can be costly. If you need to use a detector in each beam pocket, a lot of customers are using air sampling detection, running the pipe network, as you can see here, a couple of fashions. You can run the pipe network below the beam pockets, then with a simple L channel inside each beam pocket. So it's still one device in lieu of now placing one smoke detector in each one of those beam pockets. And you can run them in an L channel, or you can run them in that serpentine fashion. Is one better than the other? Not necessarily. Just all depending on the job and the installation and as far as the size of the pipe network. The one below, when you start running into maximum pipe network designs, the one below may not be the choice to go with because of the number of elbows needed versus the one on top. But it's site dependent or project dependent. I believe I'm going to pause at this stage. If there's any questions,
we do have a couple more, Luis. So yeah,
okay, absolutely.
The question on the cold storage and heating the air, they're asking about, are there certain heaters that are preferred to do that, or how is that completed?
In that application guide, there's a couple of ways, approaches we take. In the application guide, again, that white paper that they can download from our website, there's the use of the heat tape on the pipe network before it enters the detector. Okay, so we can heat that air sampling, or use the outside environment. So let's say, the freezer or the refrigeration unit, the detector, the FAAST unit itself is going to be mounted outside of this area, of course. You can then use that ambient air temperature in which the detector is physically mounted. We can use that to heat up that cold air prior to entering the detector. And it could be in a manifold scenario where we have a bunch of pipe in that space prior to entering the freezer, so that'll cool it, that'll warm up that air before it comes into the detector. Or you can use that heat tape, as I mentioned. But either way, it can be designed accordingly to meet that. And we show how to do that, how to both approaches.
Okay, all right. Question on application within an airport hangar. They're currently using a beam detector or beam detectors, and that they're getting some false alarm when the doors open, dust blows up, or morning fog rolls in. Must be maybe a coastal area. Would FAAST be a better use in that application?
Yeah, absolutely, absolutely. Again, these applications or these frequently asked questions we get are just the most common. There are other applications, but yes, in an area like that, you probably have the issue of high ceilings as well as to the condensation. So we talked about the condensation. You can have the detector drip loops to catch that. High areas, we recommend the ceiling protection across the ceiling, but then we also recommend, in these high ceiling applications, is side protection on the side walls. Yes, the issue with beam detectors is, especially when there's building shift, you may get out of alignment with beam detectors. You're not going to have that issue with piping, obviously, because the airflow is coming through the pipe. Yes, there are a couple of places, but yes, air sampling would be a good fit. Again, I guess the idea is to think of air sampling when you have traditional detection, where it could be a potential problem for traditional detection. You should consider air sampling as a solution, because many of the times you'll see it'll fit perfectly in that environment. And we can help with that layout and design.
Okay, very good. We do have a couple other questions, but why don't we go ahead and finish the presentation, and then we'll get to the rest of the Q&A.
Okay. Well, just a little bit on FAAST for those who are not familiar with the FAAST unit. It is a single pipe. It is a single pipe system. Covers 8,000 square foot standard detection coverage. The dual vision sensing technology, again, as I mentioned, two sources, not one source, to confirm what that particulate is inside the chamber. If it's a dust particle, the infrared laser analyzes it. We reject it. If it's a true product of combustion, we look at its signature, shape, size, color, and then we confirm very accurately for an alarm. Particle separator, that's the first stage of filtration of the three. Three stages of filtration. Every unit comes with a integral Ethernet connection, so it can be tied to the building's IT infrastructure. It will get an IP address, just like a PC would on that network. And then the detector itself, the FAAST unit, is an email server and a web server as well. It's all built in. There are no different models to purchase to have all this, features if you'd like. Every unit comes with it. And then simplicity and integration. If you're using the conventional FAAST, you would relay contacts to make the connection to the fire system. You can connect it to a module on an addressable system, or connect it to zones of a standard conventional system. And there are also addressable versions of FAAST out there. You would just reach out to your panel manufacturer to see if it's available, and it would sit on the SLC loop, just as your traditional spot type detectors and modules sits on the SLC loop. As I mentioned, just reach out to you can either reach out to the panel rep for your particular panel that you generally work with, or reach out to the system sensor RSM in your region, and they'll be more than happy to give you if it's available for that system, and if it's not available for that system, when will it be available, because they are coming down the line. And also, part of the Ethernet connection, we are adding the Modbus capabilities in the very near future, so that if it's part of your building management system, you can also connect it to that as well. What's next? If you do have an application, as I mentioned, if you're looking for one of these challenging environments or mission critical, whatever, we do have a dedicated design team which would be more than happy to assist you. It is free. There's no cost associated. Just simply ask you to go to that link there. We have a simple form that we ask to fill out. You fill out the information on that environment. Supply us with if there's a print you have, that will help. Fill out the answers, and what we'll do then, it'll be sent to our design team, and then our design team in turn will send you a bill of material and a pipe layout report. A bill of material you can use to quote the job. It'll tell you if you're going to need multiple detectors to do that area, how many elbows, how many, total amount of pipe you're going to need. All that you can quote the job. And then the other report is the pipe layout report, and that's the one that's going to tell you how many holes, what size sample holes you're going to need, and so forth for that system. And then, of course, you can also reach out to both Krista and myself, and here's our contact information for that. We'll be more than happy to help you out with that.
All right, good. At this point, we do have a couple more questions posted. I'm also going to launch it's not really a poll question, but if you have a need for any of the items listed on the slide at this point, Pipe IQ software, Kristen Luis mentioned that's our design software that works with the FAAST system. That is complimentary, and we'd love to get that to you. As both Kristen and Luis mentioned, we do offer a layout and bill of materials service. So if you have an interest in that, go ahead and check that. Perhaps you'd like to see an in-person demonstration of FAAST. You like what you see so far, and you'd like to see that. Please check that. We do have some literature that we can send you getting started with FAAST. It's a packet. And then we are offering in many cities across the U.S. and parts of Canada a FAAST certification training class. So if you're interested in that, check any of those that apply. I'm going to leave that up for a little bit while we're answering questions here. A couple of questions on the India project. If you know some details, was that a code-driven requirement, or was this the aspiration use above and beyond code?
It was a code. It required detection in the space. There was many units in that particular project. They're not all in the high, the high ceiling area, the atrium areas, but the code did require that they have them across that spacing. But there were computer rooms, there were harsh switch rooms and harsh environments. So they just used quite a bit of them throughout that airport. But it was code driven.
And do we know if sprinklers were also used, or do we have that level of detail? I know it was designed, I think, in India, but
yeah, I don't know. So we don't deal with the sprinkler. We don't get involved in the sprinkler design portion of it.
Okay.
But I couldn't answer that. Sorry.
Not a problem. A couple questions related to the Manitoba prison. Do we know how they made the points tamper-proof? Were they disguised or were they shielded in some place, somehow within that facility?
I don't know the specifics on the Canadian as far as the air sampling points. However, in some here in the States, I have designed with some engineering firms where we've hidden the capillary points inside light fixtures. In other areas of the cell, they very discreetly put them in there. But I'm not, unless Krista knows more detail on that.
Also, stainless steel sampling points that are used in areas where tamper resistance is a concern.
Mm-hmm. Okay. A couple people have asked that question, so maybe we'll follow up with them directly on what the application might be. And another question related to Manitoba. They believe you mentioned that there was a single detector per cell. Is that correct?
Correct.
Okay. And did that provide a component of addressability by going with a single point per cell?
Yes, exactly.
Okay. Was that okay? Very good. That answers
the design.
If a project is looking for point identification, obviously we have spot type detectors that are listed for very early warning in those environments, depending on the panel manufacturer. But in this case, obviously spot type detector couldn't be used in the cell because it could be tampered with. So that's why they chose to go with one device per cell.
Yep. This attendee says he has application with wide and tall and open corridors.
Okay.
There's often banners or flags or balloons or other sorts of advertising. Maybe this is a atrium in a airport or something. Can these obstructions obstruct the smoke detection, ASD smoke detection?
Typically, the answer, without looking at it, is no. These certain items would affect, obviously, beam detection operation in these areas. Again, we say banners. If it's a banner that's the size of it's acting as a wall, then we have to take, wall considerations into play, and keep treating them as separate environments. But if it's, banners, balloons, and things like that of nature, no, they will not affect. They will not affect as far as, the piping network goes and the level of detection provided by ear sampling.
All right, very good. Next question relates to covering an area that's also protected with fire-rated walls, and they're wondering how they would run a piping network, over, around, through fire-rated walls, so that you could use the 8,000 square feet to the, to the max.
Okay. Yep, sure. Obviously, when you're penetrating a fire-rated wall, you have to take all precautions as far as the the sealing of the holes and the penetrations. However, when you're dealing with air sampling systems, regardless of whose technology you use in the market, you have to be very careful when protecting multiple spaces, and that's due in large to pressure differentials. If one space has a different pressure differential than another space while using one detector to cover both, you may run into flow issues where you're not be able to balance the system, and that's not a limitation to a certain brand out there. It's just a limitation to air sampling technology, theory and period. So while that can be done, certain considerations and has to be taken into account when you're doing multiple areas. But as far as penetrating the walls, you do have to treat that with installations and so forth as you would when you're penetrating it with any other material.
Okay. Next question I can answer, are CEUs available with this class? The answer is yes. We didn't when the initial invitation went out, but we were able to secure certification for that, and we will be sending, for those of you that joined us for the complete webinar, we will be sending out certificates here within about 3 days, and that will list the 0.1 CEU credit that you've earned by attending today. Luis, this probably is back to you. They're talking about the beam application, and are they saying should we recommend, or let's see, are we testing at the bottom of the beam, or do we go up into the beam pockets?
When we design them, we do both.
Okay.
We do both. You're not adding any more cost to the device, right? It's not like there's spot type detectors where you need to put one, in every location below the beam in that beam pocket. It's one device. It's the same FAAST detector, depending on obviously the size of that. Then it's just one. It's just a matter of installing holes. So we do call out for below the pockets as well.
Okay.
So in the pocket and below the pockets.
Very good.
And another note I just wanted to put, as you mentioned here, PipeIQ software is complementary ASD design software. That's the same software that our design group uses to design the system. So you're getting the full, if you go to systemsensor.com, it's free of charge, the software, and it's the same software that we use to design systems. Just wanted to make that note. It isn't a downgraded version of it.
Okay, very good. And that answers one of the questions: is there required software to use with FAAST, and that's the PipeIQ. So I think we've clarified that. What about length of pipe restrictions? Is there a maximum length of pipe?
Yep. There's a couple of we recommend maximum, and these are rule of thumbs. Just so if you're trying to design or quote a system, you have an idea how far you can run these. A single pipe run, if you're doing a single pipe run with no T's or anything, just let's say if it's linear or if it's in a serpentine fashion, the maximum run is 262 feet of pipe. Okay. Total amount of piping, total amount allowed for the system is 328 feet of pipe. So that's when you start adding T's and bends and so forth. When you start adding a lot of those, the total number, which the software, again, the software is very user-friendly when you design a system. It does not allow you to go outside of the operating specs of the product, so it's not like you can mistakenly design a system that is not going to be compliant or that won't work. So that's all fully supervised.
Okay.
Via the software.
Guys, we do have someone from our System Sensor India facility online with us, and he's indicated that the India Airport project also had sprinklers, so we can clarify that during this call. That's nice. Thank you.
Great. Thank you. Yep, thank you.
What about applications within elevator shafts? Is that applicable to ASD and FAAST specifically?
Well, typically what I've seen for elevator shafts, and we're talking about elevator shunt trips and so forth, is the use of a heat detector technology. If smoke detection is required, or you'd like to provide that, because obviously smoke detection is it's an advanced detection over heat detection. Yes, an elevator shaft is an ideal application for it, considering the harsh environment that it's in, or that's present with an elevator shaft. Air sampling would be ideal for that application if you wanted to provide that smoke. But traditionally, it's a heat detector or a heat device that would be used for for an elevator shunt trip.
Okay. All right. What kind of recommended performance testing is used at startup?
Okay. After the unit's been installed and commissioned and so forth, we do have a startup procedure in the manual. We recommend you testing 100% of the holes. Obviously, that's all AHJ dependent. Some AHJs will allow for the furthest holes or end cap ports to be tested. Part of that software or part of the reports that we can provide are transport times, hole sensitivities, hole pressures, hole flow rates, and all of that stuff. We recommend we recommend to test 100% of them, but many AHJs out there will allow you to test the furthest ones and then compare the values or the numbers you have reached per the report, and then they accept the report. But that's all called out in our installation manual.
Okay. All right. This may be more of a marketing question, but they're saying in their area fire marshals or AHJs don't accept aspiration technology. Has that been our experience? And what's a good approach in getting aspiration to be able to use in a jurisdiction?
I have not heard that, actually. I don't know if you have, Luis.
I don't know as to why. I would have to know why. Is there a particular reason why they're not allowing them? I know when beam detector technology first came out, it was it had the same sort of hurdles with the AHJ community, and that seems, in many cases, it just happens to be because of what the technology is, and if they're not familiar with the technology. But if there's anything, you know, these particular whoever asked the question, is they want to reach out to us. If there's a reason why you know, they're not allowing it, we can you know, we can look into that.
Okay.
It's likely an education issue that we could probably help with. Maybe invite them to one of our training courses. And make them feel more comfortable that, you know, it's not a new technology and it's proven in many installations.
Right, right. Very good. We got time for a couple more questions here. We're coming up to the top of the hour, and we do want to respect your time. What type of piping material should be used in ASD design?
Well, the primary, or I should say the called out or listed product piping is the CPVC material, which is typically in the orange color. CPVC is the one that's listed. However, the FAAST unit can accommodate other material. It could be PVC, it can be copper, it can be steel, it can be ABS, PE, the flex, you know, the flex black tube or the solid black. That's all dependent. The crucial element to a design or when you're designing system is the inner diameter. Even if it's a retrofit application, the crucial element, if you want to use the existing pipe network, is the inner diameter, and we're listed within 1/2 inch to 3/4 inch inner diameter. So we can accommodate other materials, but as far as listed is the CPVC stuff, you know, with the piping material.
Okay. Maybe the final question here, how can this system be attached to a building automation system?
Okay, currently we provide the Ethernet port that will tie, you know, the IP. You would grab an IP address like a PC would on that infrastructure. You have that way of connecting. You have the SLC loop version of connecting to the fire system, and then, as I mentioned, in the near future, we are going to have the Modbus capabilities on the Ethernet port, which then will communicate Modbus to that building infrastructure's building solution infrastructure.
Okay, very good. Well, we are at the top of the hour, so we want to appreciate your time here. On behalf of System Sensor, on behalf of Krista and Luis, I want to thank you for joining us today. As a follow-up, we will send you a brief survey in about 2 hours, and would appreciate your help in filling that out. And we do plan to reward one of you that completes the survey with a $50 Amazon gift card. Once again, thank you for joining us today. This does conclude our survey, or our webinar rather. Please have a nice rest of the day.